from image you move to that 128-bit space, then you do a clustering, right? Obviously, then you can search much faster, right? You can, for example, do maybe order of log n or whatever, right? Search could be that fast based on, but we are in the process of building it. Hopefully, we'll have something. Yeah. Maybe I'll come back to you. Yes, sir. You had your question. Right, right. I just saw that. So we were in the process of figuring out, what are they doing and how are they doing it. And I think it's still not aware of GPUs. So we still have to do something to make it aware of GPUs and do that. Yeah, but you're right. 1.3 does attempt, it's no more a dumb kind of scheduler. It's able to look at the computational power of the node and it's able to schedule accordingly. But still, yeah, it has to be taken to the next level as well, trying to look at GPUs. I think there are two questions. So
I would like to, I'm very sorry to interrupt. We are
running out of time.
We got to conclude this session. Maybe the questions could be taken off on
but we're anyway on a tea break, right?
No, what we have planned is that we'll start off with the last session. After that, we'll have the tea break.
Oh,
correct.
Sure. But I'm going to be available, so we can take questions.
Sure. He'll be available. Maybe.
So, and you have one more, right? All right. Thank you.
So this is a certificate of appreciation from Unicom to Mr. Vijay Srinivasan. Thank you, Vijay.
Thank you.
So as I said, now we'll have the last session of the day, and then we can have the tea break, and you can take up our offline question and answers as well. So now I would be calling Mr. Biju Varghese, who would be taking you through the last session. He is the engineering director of Global Logic.
So guys, initially I prepared my presentation to talk more about, you build an analytical system, and just wanted to go through each and every step and figure out what would be the security considerations which you would be interested to keep in each layer. That was my intention when I started off. Then I realized that my time is from 4:15 to 5 o'clock on a Friday evening, and which is not the right time to do such deep stuff. So I thought, let's make it a little lighter, and so I would just throw up some ideas for you which you can probably think through it, and which you could take it for the weekend thought process. So I've put up some numbers here, which is which is pretty hypothetical plus it's a data scientist numbers, whereby it's some of the information says that in our galaxy there are approximately around 3 to 10 raised to 11 stars, as compared to the number of stars available in the whole universe, across galaxies are going to be 10 raised to 23. And I have put a big red line in between. That is approximately, that is at 10 raised to 21, which is nothing but a zettabyte. The importance of that particular line is that that's the amount of data storage available with us right now. You can imagine the kind of data storage we have right now. Okay? So I'll come to the time when I'll come to it. Why am I coming up with these numbers a little later? But just to chew in the numbers a little bit more. Just imagine, in the in our planet there are approximately 10 raised to 11 trees. That's some statistics, and I have given the links from where I picked up this data here. But this is some basic statistics which I got from somewhere. So if you look at that number, the laptop which I'm having, which which generally has 1 terabytes of data right now. If you look at it, if I have these many trees, 10 raised to 11 trees, which means that the 1 terabyte will be 10 raised to 12, which means that I'll be able to store every tree's information with me. Am I correct? I'll be able to store another 10 more bytes I have, probably 4 bytes for my lat and 4 bytes for my long, and then probably type of the tree, maybe 2 bytes. Am I correct? So which means that I'll be able to store In my laptop, the entire trees in this planet, information about entire trees in the planet. So that's the kind of data storage which we are having it right now. Okay? So similarly, another important thing is that this 10 raised to 15, that is the number of trackable things identified, in our Earth which could be tracked. Okay? Why am I telling about all these numbers? We'll just get into it. So, which means that if I have 10 raised to 15 things in the world, and approximately I have 10 raised to 21 data storage capacity available, we should be able to track approximately 1 MB of data per thing in the world. You take the chairs here, you take anything in the world, you have the data storage capacity of storing 1 MB of data. Am I correct? It's pretty interesting statistics for us to know. It's for us to realize that the kind of computing power, kind of storage capacity we are having, getting into our day-to-day life these days. So why is it so significant? Because we have reached a point where it is technically capable to realistically store data of anything we want. And which means that when there is technology becomes cheap, you will have business case associated with this as well. Okay, so going a little bit, reasons for it, which is anyway pretty much everybody would know what are these things all about. But so from 2005 onwards, our cost of processing has come down by 100%, 100 times, which is pretty significant a change. Whereas your data storage as well as your RAM cost has also come down drastically. Okay. Apart from this, we have another statistics which I'm just putting out. It's another interesting thing. The number of smartphones getting activated per day is much higher than the babies born. Okay? So much of things which I just said now. We have enough of storage possible right now to store the information about anything in the world. We have the connectivity available, which is getting much, much bigger. And it's getting into a stage where we can connect anything into the world. Okay, so now let's take a step back and figure out why did I give all these numbers right now. Okay, if you look at the successful companies in mid 90s, you had the evolution of World Wide Web. Okay, that time these set of big companies have grown. What was the significance of that mid 90s? That was primarily World Wide Web, and you could have your static. And what is the difference? Can anybody think about a difference? What is the difference between these two major differences? Major difference, which I would think, is that in this case it was a one-way communication primarily, where people used to publish data. In this particular wave, what had happened is that people started sharing data. Okay, so it just became a little bit more social, and more data started coming in, which was not the traditional World Wide Web in mid 90s. And now we are in this 2015, and people keep talking about IoT, Internet of Things, Internet of Everything, this, that, and a lot of jargons around that. Now, what is the difference from analytics point of view in 2015? The biggest difference what we are seeing right now is that till here, it was the humans which was trying to send data, and that was our primary way of data collection. But whereas when it comes to IoT world, there are a lot of sensors lying all around the place, which is sending the data. Am I correct? There's a lot of sensors in your phone, in your public places, in your houses, wherever you go, there are a lot of sensors which is going to be sending a lot of data. Am I correct? And the things which I just mentioned at the beginning of my talk, it's sending the information about these things, which we use it. Okay, and there is another key change which is happening apart from these sensors sending the data. The key difference is that earlier you do a big data analytics, and what would happen is that you generate the reports, the business reports, which somebody would look at it and say, okay, yeah, it's pretty good. I'll take this decision, that decision, whatever it is, based on the analytical reports which you get. But now what's happening is that we are using this analytics and machine itself is taking decisions. Am I correct? So the way in which the big data analytics area is being focused on, if you look at it, the data is coming seamlessly and it's coming as a big stream of data coming in, and the decisions are also taken care by machines itself. It's not taken by any human intervention in between. Okay, so that's the evolution which is happening. And coming to our world of big data analytics, the biggest change I just mentioned, it's a stream of continuous data flowing, and and you will have your systems which is acting upon it. And but you still not changing your 3 V's of your big data analytics, which is going to be coming in picture. And looking at it, you will have 200 billion devices supposed to be connected by 2020, which is kind of the biggest opportunity for the big data analytics engineers, which is there in the market right now. Okay, so what I have done is that I just, whatever I just mentioned about it, I just put it up in a little bit technical diagram, whereby you will have lot of these sensors which would be generating a lot of data, comes to the whole processing unit, and then you will have some systems taking appropriate action, whether it is to manage a traffic network, to manage a car, anything for that matter. You can divide this into 3 different planes. And for us, the key important point which we wanted to do it is on the data processing layer, which would be either predictive analytics or business intelligence is what we are going to be talking about. Okay? So if you look at this particular diagram, you will have your data coming in, and you would have to take 2 kinds of decisions quickly. One is the fast decision making, which is kind of the kind of whenever a data comes in, you might want to take some quick decisions so that you take some business decisions quickly, rather than waiting for your deep analytics engine to predict and figure out what's the kind of information which you needed. And in some cases, you might want to go into the deep insights, and you wanted to do your predictive analytics, as well as you conduct the external systems to pull the data. You wanted to take care of your historical data. You want to run batch processing, whatever you want, but you will have a deep insights to do that. And combine these 2 results, and then you figure out what would be the actions taken. It could be complex work actions, or it could even be a simple alerts which comes to your mobiles, or anything for that matter. Okay. So technically as well, the world is changing from what I just mentioned. So let's get a little bit deeper into some of those fast decision making engines. So when we talk about fast decision making engines, I'm talking about the decisions which needs to be made sub 1 second, like 500 milliseconds or 200 milliseconds, depending on the business case you want. You might want to take decisions at sub 1 second. So that's what I mentioned it as fast decision making engines. We need to do these kind of to cater to the new world. So we are building few products in those areas from GlobalLogic, and we use these are the kind of design consideration we need to keep. We need to make sure that we are able to queue it or cache the data. We should be able to do complex event processing, and we should be able to stream analytics as a part of this fast decision making layer which we are talking about. And few of the open source technologies also, I just mentioned it, which anyway all of you here in the room are pretty familiar with, but just to get a sense of what I was trying to talk about. So then we talked about this quick fast decision making engines which could be used to take fast decisions. But the next set is the deep insights, which is nothing but your typical BI kind of a system, where you will have your data integration, data storage, analytics, data presentation, etc. So it's just the typical BI systems which you would be having. So if you look at it in the future, your analytics system would be a combination of these 2 things together. You need the deep insights, plus you need fast decision making engines running parallelly to take decisions. Okay, that's the way I think that the world is going to be moving going forward, to take care of the Internet of Things kind of a network which we wanted to build in the future. So there are some of those fewer technologies which we have used to build these deep insight things are also mentioned there for your reference. So I'm pretty sure that all of you would have been very familiar with the Lambda architecture. You would have been listening to this in the course of the day from multiple people. But just to give you that perspective, whatever I just till now, one of the which one of the best kind of implementation we have seen. I will never say that this is the implementation, but one of the good implementations for us to achieve this particular thing could be on the could be implemented using Lambda architecture. Using, I never meant this is the only architecture, but you might want to build things on top of it to get your speed layer as well, to be more fast decision making engine. So it's, if you look at it, exactly the same thing was happening. You will have your speed layer, you will have your speed layer, you will have your batch layer, and you will have your serving node which would be doing it. So if you look at the other providers in the big data analytics area, if you look at their solution, their evolution which is happening, so everybody is moving towards this particular framework of supporting your batch processing versus the speed layer processing. So it's going to be a total shift in your game from how you used to do in your previous big data analytics to the new age Internet of Things kind of a network. Um, let me come to my one of the key things which I actually wanted to talk in detail earlier, which I changed. I said primarily due to the time which I'm talking. But anyway, I thought I'll use the same logic and tell that